Okay, here's a nice little question concerning a cubic function. Um, the information about the function is given in function notation. So part of the skill here is interpreting what these statements mean in terms of the graph. So let's let's have a look at that first. And then we'll look at what the question is actually asking us to do. So firstly, what does h of naught equals 3? What does that actually mean? Okay, so this means that x is naught, and then if it equates to 3, that means that y is 3. So in terms of the graph, we should understand that that means that the y-intercept is 0, 3. Okay. Um, this statement h dash 2 equals h dash 4 equals naught. Okay, so that means h dash is the derivative. Of 2 means at x equals 2. And then if it equals 0, that means that the gradient of the function when x is 2 is 0. And that is true when x is 2 and x is 4. So this statement here, h dash of 2 equals 0. Let's write them separately, h dash of 4 equals 0. What we're saying there is that we have stationary points at x equals 2 and x equals 4. All right. And then finally, h of 2 equals 2 means that we've got a point 2, 2, x is 2 and y is 2. So that means that at this stationary point here, h dash of 2, that means that the stationary point is actually at 2, 2. All right, so now, well, now that we've interpreted that, what's the question actually asking? It says, how many real solutions are there to the equation h of x equals 0? Okay, so now we're wanting to solve an equation, but we don't actually have that equation. So what this question is wanting us to do is to deduce from the graph how many real solutions there would be to the equation h of x equals 0. So again, we've got an interpretation here. What does h of x equals 0 mean as regards the graph? So we're saying h of x is the y value, so y equals 0. That means that we're talking about the x-intercepts of the graph. All right, so the number of x-intercepts of the graph of h is going to lead us to the number of real solutions that there are to this equation h of x equals 0. All right, so we've got options 0, 1, 2, 3. If we know anything about cubic graphs, what do they look like? They're kind of, they can look like that. They could look like that. You could have this kind of graph where it comes to a stationary point like that, or it doesn't have to actually have to have any stationary points at all. But what we can understand about each of these is that it must pass through the x-axis at least once. So A cannot be an answer. All right, but 1, 2, and 3 are all possible answers to the number of solutions to a cubic expression being equal to 0. It can't be more than 3, but it could be 1, 2, or 3. All right, so now let's put this information onto a graph. Let's see what this graph actually looks like. Let's draw ourselves some axes. It's a little bit of a problem-solving exercise. What could it look like? We know we've got a y-intercept of 3. Right, so that's 3 there. We then have this point 2, 2. All right, and we know, so not only is that a point at 2, 2, but we know it's also a stationary point. All right, so if the graph is coming down from this y-intercept and it's hitting this point here, we know that's a stationary point, so it must go up like that. What else do we know? There's another stationary point at x equals 4. All right, so that means that it must turn there. and then it's going to come down. There's no other information given, so the graph is basically the carry on down there. We know it's a cubic graph, so that's given. And then, so this is these are the features of a cubic graph. And we can see from this graph and from the information given that it's going to hit the x-axis only once. And therefore, how many solutions are there to the equation h of x equals 0? There's only one.